So in this video, we'll be going over how to add some UI elements to your application. So once you have the map loaded, you may want to add some components such as floor selector. So what you have to do is open your pod file. We have a UI kit that works with our SDK. So you will have to add another line here called UI kit -iOS -pod. And then it's also in a Git repository, https github.com/jibestream/UIKit-iOS-pod. So now you can save it, close that, open your terminal, and do a pod install on the project directory. So after this, you should see that you have fetched the latest UI kit. And it is also in your project. So now you can open the workspace. You can double check by going into pods and see that the UI kit framework is indeed there. So now you would have to also import this UI kit into the bridging header. So import jmap UI kit. jmap UI-kit.h, and then that should be good to go. Go back to your view controller, add the delegate method for the UI kit, and we'll create a UI kit variable called map UI kit. And then we can go ahead and initialize it. So upon the SDK successful initialize, we can add this to also initialize the UI kit here. So we'll do self.map-UI-kit jmap UI, and this takes in a controller, a view controller, and any options that you want to pass in. We'll keep that as null. And we'll also have to set the delegate to be self. And then in the storyboard, we'll have to make some changes because the map UI elements actually goes on top of the canvas. So we'll have to make an update here. We will unlink the canvas, convert this back to a general view. And then we would have to add a new view. So we can just drag and drop a view onto the storyboard. And then we will have to make this the canvas, and then also link this back to the view controller. And now you can go back to the view controller and we can start initializing some elements. So let's start. Oh, there's an error. Exclamation mark. So let's start with the floor selector. Load floor selector. And we can start by initializing some option variables. So let floor selector option, and we'll set a position for this. Let's make it 0.9, 0.95, and make it 0.9. And then we can call render floor selector directly from the map UI kit. So self.map-UI-kit.render floor selector, and then we'll pass in the options as the floor selector option, and then we can run it. So the position in here is referring to the device relative position. So 0, 0 would be the top left of the map, and 1, 1 would be the bottom right. So here I need to include also some implementation for the delegate method. So we'll just leave that blank for now and run it again. So on the simulator, you should see now that there would be a floor selector on top of your map. So right there, you'd see saying L1, and then you can also toggle to different floors. You may see that it's not quite in the right position, and that's because we haven't defined the layout of the canvas. So you would want to check all these to ensure that it takes up the whole device screen. So run it again. And now you just see it's at the bottom right corner. Okay, so now let's move on to the next component. We can do load the compass. So similar to floor selector, we'll have a compass option. We'll also set the position for this. Let's make it 0.05 and 0.9. So this will be in the bottom left corner of the device. So we can also define the width and the height. Let's make that 75. And we have to define this as a string to any dictionary. And then we can call render compass and pass in the options for that. And for the compass, you would see once you run it, it would appear on the bottom left hand side of the screen. And you would also have to add in an update to ensure that the compass reflects any gesture rotations. So in here, you would have to add the SDK delegate of reading the rotation. So scroll view did rotate by degrees, and we have to update the compass in the Map UI Kit with the degrees that gets sent back from the delegate method. So if you run it again now, you should see that if we rotate, the compass will actually rotate accordingly along with the map. And also there is an additional feature that the compass has, which is if you click it, it'll convert back to north facing, which is the default orientation of the map. So now let's load another component, search bar. So once again, we'll have some search options. So we have a placeholder. Let's put that as the search bar as text. And then there's also a max results, which limits to how many results is visible from the dropdown. Let's put that as 3. And then this position defines where it is on the screen. So 0 would be at the very top and 1 would be at the very bottom. So now we have to define the dictionary as string to any, and then call Map UI Kit, render search, pass in the search options, and we can run it again. And now you should see a search bar at the top. So if you click it, start typing anything, and the search bar by default shows all destinations, amenities, and path types. So what you want to do here is start the implementation for handling what happens when you select something from the search bar. So right here, we want to check if the item that gets returned is a destination object. So if it is, then we want to cast it as a destination. And right here, we will want to see if the destination is on the current map or not. Because if it isn't, then we would have to change the map and then highlight the destination. So we have to do a check here to see if the destination's map ID is the same as the current viewing map ID. So in this scenario, if it isn't the same, we would have to call show map, which would switch the floors for us. So now we set the map object to be whichever map that the destination is on. So get by ID, destination, location, first object, map ID. So now we can call show map with that map object. Self.control.show, and then go to map, pass in the map object and the completion handler. So if it is successful, the map will be shown, and we would have to call to highlight the shape, and also we would want to zoom to it. So let's make a new method called highlight shapes at destination. We'll implement that afterwards. So if the destination is on the same floor as the current map, so it's already on the viewing floor, then all we have to do is call this method directly. So now let's implement highlight shapes at destination. And we'll take in a destination object, jmap destination. And what we want to do here is basically get the shapes from the destination. So control get unit from destination, pass in the destination. This will give back an array of shapes for the specific destination. So now what we can do is get the bounds of the shapes so we know where to zoom in on the map. So we'll define a bounds variable, and we'll access the path frame, which is a CG rect. So what we want to do here is actually check to make sure that there is a shape associated to this destination. So only if shape count is greater than 1, then we want to do this. So the bounds is a CG rect. Then we can call the SDK to fit bounds in view, pass in the bounds, and now we can also highlight the destination. So then now we have to define a styling for it. So highlight via jmap style, and then we'll set the fill. Let's make it blue. And then now we can apply the styling to the shape itself. So self-control dot style shapes, pass in the shapes array, and the styling will be highlight. So now let's try running it again. And we'll just search a destination. Let's do the bridge, and when you click it, and now it zooms into the bridge unit and also highlights it blue. Now let's try another destination, captain's quarters. It zooms into it and highlights it blue. So that's how you would style the unit. And this is how you add the components to your application.